Hi, welcome to Raw Math. Today I'm doing a series of videos on solving polynomials that are a little bit different. Well, polynomials and radicals and rationals. This one is a radical. So it doesn't look pretty. We have two radicals. I want to start by moving this radical over to the 1 before I square, separating these, so that when I start squaring things, it's going to be a little less ugly, because with squaring radical after radical, things can get pretty ugly. So my first step is to move this over. So it's plus the square root of 2x plus 3. And then I'm going to square both sides. And when I square this side, what I'm really going to have is 1 plus the square root of 2x plus 3 times 1 plus the square root of 2x plus 3. And I rewrite it like this to make sure I don't miss any terms. And I'm leaving a little space because I'm going to square this at the end. I'm going to distribute the 1. 1 times 1 is 1. 1 times the square root of 2x plus 3 is the square root of 2x plus 3. The square root of 2x plus 3 plus times 1 is the square root of 2x plus 3. And the square root of 2x plus 3 times the square root of 2x plus 3 is the square root of 2x plus 3 squared. Now, I'm not going to get rid of the inverses of the square root and the square yet, because I don't want to lose anything. This will come down as 1 plus 2 times the square root of 2x plus 3. These will cancel, and I'll be left with plus 2x plus 3. And then when this squares, make sure you don't forget this 2 has to square. 4 times x plus 1. All right. So you might want to pause and look everything over because that was a lot that just happened. I'm going to bring this as 4x plus 4 equals, I'm going to combine my 1 and 3, so I'm going to have 2 times the square root of 2x plus 3 plus 2x plus 4. I'm going to bring the 2x and 4 over, so minus 2x minus 4, and it's going to be 2x equals 2 times the square root of 2x plus 3. Now notice that these both have a 2. So I am going to divide by 2 to get rid of the extra 2. And I'm going to have x equals the square root of 2x plus 3. And then I am going to bring, well, I think I can, there's space here. And then because there's a square root still, I need to square again. So I have to square a second time. So I square the x and I square this. But I want you to notice that this time, I don't have to do any distributive property with stacking. I'm going to end up with x squared equaling 2x plus 3. So this I am going to move up. X squared equals 2x plus 3. I'm going to move everything over because I have variables in more than one term. I'm going to have to factor. And because I'm going to have to factor, I have to have everything equal to 0. So I'm going to subtract the 2x and 3 over. So I have x squared minus 2x minus 3 equals 0. And I have a trinomial. A is 1. I need two numbers that multiply to 3 and add to negative 2. So plus 1 minus 3 adds to negative 2, multiplies to 3. X plus 1 x minus 3 equals 0, which means if x plus 1 equals 0 when x is negative 1, x minus 3 equals 0 when x is 3. We have two possible solutions, but we have squared twice. And when you square once, much less twice, weird things happen. So we have to go back and check our work with the original problem. So if we check x equals negative 1, the question becomes, is 2 times the square root of negative 1 plus 1 minus the square root of 2 times negative 1 plus 3 equal to 1? Well, this is 0. So, and this is minus, let's see, negative 2 plus 3, the square root of 1. Does this equal 1? So you see right here, when we squared this is negative 1 and 1. This is not equal. When we squared it, we lost the negative. So by squaring 2 times, we got a false positive. So that doesn't work. We might not end up with any solution. We definitely did not have that as a solution. If we test x equals 3, so is 2 times the square root of 3 plus 1 minus the square root of 2 times 3 plus 3 equal to 1. So is 2 times the square root of 4 minus the square root of 9 equal to 1. Well, this is 2 times 2, and this is 3, and that checks out. So this is a valid answer. And there we go. I hope you've enjoyed this video. Please subscribe to my YouTube channel, and I'll see you on the next video. Thanks.